Alright, we're going to have a quick lesson on quantum mechanics. Quantum mechanics, or how do I send a pizza to an electron? Okay, reminder, electrons. Bohr established that electrons live, quotes, in orbits or energy levels. Okay, they need to have a quanta of energy which Planck calculated to be found by taking frequency times Planck's constant. They need a quanta of energy to move between energy levels. So if we are an electron here and we want to go to here, we need to have one quanta of energy. And we've already talked about that energy comes in as an electron or as light, and if it hits the electron, it will jump out. Okay? This energy level is the N address line. Okay? Now, electrons can only exist in certain areas, and they likened it to being like a ladder. You can't have an electron halfway in between two energy levels, just like you can't grab the rung of a ladder that's not there. If you have n equals 1, you're going to have one wave, really a half of a wave if you look at it this way. N2, there's going to be a couple waves. N3, 3 waves, and so on and so forth. So that's going to affect the number of electrons you can house in each energy level. Okay. Within the energy levels, we have sublevels that contain the orbitals. So that's where these wave pictures are coming from. Those are our sublevels. And we call those orbitals. Orbitals are fuzzy cloud-like areas that contain either one or two electrons. The electron moves so fast, it seems to impart its charge to the whole orbital, so we don't know where it is. The orbital type or shape is what we call the L address line, which is our second address line from our quantum numbers. So, to sum up so far, our first quantum number is the N number, which is the energy level. The second one is the L number, which is the shape of the orbital. The S orbital is just a circular shape. The P orbital, the circle's been pinched in half. So you have 2 lobes for the electrons to hang out in. And there are 3 p orbitals, because there's one in the on the x-axis, one on the y-axis, one on the z-axis. The d orbitals, there are 5. And the f orbitals, there are 7. So their subshells are named S, P, D, and F. So when you are asked what is your L address, we're talking about which shape of orbital you have. Okay? So, once again, the N energy level is the level they're on. The L number tells us what the shape is. The S orbital, if we're talking about L, it's 0. The p orbital, the number for L, is 1. The d orbital, the number for L, is 2. And the f orbital, the number for L, is 3. Okay? Now, the third quantum number gives us the actual room number. Okay? The s orbital has only one axis. It only has one room. So the s orbitals are only ever going to have a third number that is a 0. The third number for p orbitals are either going to be -1, 0, or +1. The third number for d orbitals are -2, -1, 0, 1, or 2, because there are 5 of them, and there are 7 of the s, -3, -2, -1, 0, 1, 2, 3. That is what we call the ml number. So when we go back up here, our N is the energy level, L is our shape. Our ml is which orbital within the shape. I can't spell with. I don't know why my picture, I don't want that there. Okay. How do we know the shape? Well, this is a nice, well, let's see, maybe it'll work, maybe it won't, because of course we're talking about me. Nothing I ever do seems to work the way it's supposed to. Alright, yeah, it worked. S orbital, you get a circular shape because there's just one wave. P orbitals, you get the pinched dumbbell shape because there's two orbitals. The D orbitals, we get 4 lobes because there are 3 waves. Okay? So you can see now, hopefully, a little bit better the shape. There's your circular shape. Here is your P shape and your D shape, which we call double peanut shape. Okay? That worked pretty well for a change. Of course, I put those into the PowerPoint, and then when I copy them to the smartboard, they don't work. All right, we just explained this. The ml is the room number. So if we use, so I'm going to redefine those first 3 numbers using our hotel method. Okay? So far we've learned the N number, the L number, and the ml number. The N number is hotel room floor energy level. So the N number for here is 1, the N number for here is 2, N number for 3, N number here is 4, and so on. The L number is based on shape. So here we have an L. The L number, possible L number on the first level is going to be 0 because S is 0. But on the second level, L could be 0, or it could be a 1 because it could be a S or it could be a P. On the third level, L could be a 0, could be a 1, and because 3D is really on the third level, it could be a 2. Our ml value, the last value, tells us which particular orbital within the subset. If it only has one orbital, like the S, we just give it a value of 0. So here, ml could be 0, but it could also be a -1, a 0, or a +1. So we've got -1, 0, or +1. With our third level, ml could be 0, -1, 0, 1. And then we go up here, -2, -1, 0, 1, 2. That gives you the first 3 numbers. The fourth number is spin. The fourth number is just going to tell us whether it's spinning. We say up or down, but think clockwise or counterclockwise, what have you. So back to our hotel. If I have an electron right here, and he's pointing up, his spin is going to be a +1/2. we call this m sub s. This guy, his spin is going to be m sub s negative 1/2. So let's put a few electrons in and get their address. I want to know the address for this electron. First of all, what energy level is he in? He's in the 4th energy level. What type of orbital is he in? He is in a p orbital, which means his number is 1. S is 0, p is 1, d is 2, f is 3. Our ml tells us which orbital. 0 is always in the middle, so he's a +1. And he's spinning down, so he's a negative 1/2. How about that electron? He is in, looks like he's in the 5th level, but remember we've got some goofiness going on, so he's in the 4th level. He's in a d orbital. S is 0, p is 1, d is 2. He is in not in the center room, he's just to the left. The center room is going to be 0, so he's going to be negative 1. And he's spinning upwards, so he would be a +1/2. Now what if I gave you a set of numbers and said go to deliver a pizza? You can tell me whether that pizza will get where it's going. For instance, if you had a number of 111/1/2, that first number refers to the energy level. The second number refers to the shape of the orbital. A 0 is an S, a 1 is a P. Do you see any P's in the first energy level? No. Therefore, the first energy, this is not a possible quantum number. Can't happen. What if we have 101/1/2? Well, we can still be in this first energy level. And now 0 does correspond to S, so it could be in the S orbital. But the next number, a 1, implies that there are more than one room. And we know that there's only one room here. So this value cannot happen. An electron right here would have a value of 1, 0, 0 +1/2. If the electron was facing down, his would be 1, 0, 0, negative 1/2. Let's try this guy. 5. I said 1 for D, and that should have been a 2 for D. I don't know if I can edit that in or not. P is a 1. He's in the 1 spot, and he's pointing up. Okay? Let's see if there's anything else to check and hit. Here's a sample. We could put this actually with a hotel map. The first level is only going to have L numbers of 0, ML numbers of 0. The second level, you could have an L 0 or 1, ML 0 or negative 1, 2, and negative 1, 0, 1. Third energy level goes up to 2, fourth energy level, so on and so forth. All right, to summarize, an S orbital has just one shape. It's round. It's a sphere. A p orbital, there'll be 3 orbitals in the p sublevel. They're peanut shaped, so you have 2 lobes, one on the x-axis, one on the y-axis, one on the z-axis. If we look at the energy levels, the first energy level can only have 2 electrons. The second energy level, oh, we skipped the second. The second has S and P orbitals. The third energy level has S and P and D. The fourth has S, P, D, F. If you have any more than the fourth energy level, not of all of your orbitals will fill up. You simply will run out of electrons. Once again, our rules. the lowest orbital fills first. Half-fill orbitals are more stable than partially filled. And so let's write some electron configurations. Titanium has 22 electrons. Its first energy level is going to have 2, 1s2. Second energy level, 2. And 6 p's for a total of 8. Third has 2 s's, 6 p's. The fourth energy level, I did that wrong. The fourth energy level has 2 s's, and then we get back into the third energy level in the d level. Let's count our electrons. 2 plus 2 is 4, plus 6 is 10, 12, 18, 19, 20. We need 2 more electrons. There'll be 2 d electrons. If we were going to draw those guys out, 2, 3, 4, 5. A d level has 5 orbitals. This guy would be 0, -1, -2, 1, 2. Our 3d would have 2 electrons corresponding to 2 of these rooms. So this first electron's address would be 3, 2, -2, plus 1/2. Our second one would be 3, 2, -1, plus 1/2. All right. Hopefully that helps explain.